So for example 1, we're going to find the domain and range for the function f of x equals the square root of x. Here we have the equation and graph for the square root of x. And first, let's look at the domain of the function. So what we want to do is, let's look first at the equation and then go to the graph. So when you're looking at the domain, you want to think, all right, what inputs can I put into my function and for x? And is there a point where I would have to stop, where I would reach some discontinuity or eventually reach infinity or negative infinity, right? So you can kind of play with numbers here. If you substitute in any negative number in for x, think about what would happen. The square root of a negative number is what? Well, if you take the square root of a negative number, you're going to get an error in your calculator, right? It's an imaginary number. So for this reason, you don't see the graph of f of x go past, in the left direction, the y-axis. Notice how the entire graph of the square root of x is to the right of the y-axis. The reason for this is because if you try to take the square root of a negative number, like for example, these x values over here, the square root of negative 4, well, square root of 4 is 2, but the square root of negative 4 we can't do yet, right? So that's why the function is not over to the left-hand side of the y-axis. Okay, so now let's try substituting in 0 for x. So if we input 0 into this equation, we get the square root of 0. All right, so the square root of 0 would be 0, right? Because 0 times 0. So our input, x, is 0. Our output is 0. Why? So the point on the graph would be 0, 0. And that's right here, the origin. Okay? So since we can't input any negative numbers, right, that didn't work. So that can't be included in our domain. But we can substitute in 0, right, for x. We get out an output of 0. This means that our domain is going to start at 0. Okay? So when we find domain, we're looking for the furthest most left value on the graph. So let me show you this. You can use like your finger to trace over with me. But as you follow this function to the left, where does it end up stopping, right? What x value, not y value, what x value, so I'm talking about on this axis right here, right? At what x value does it stop going to the left? Well, we just figured out that's at 0, right? Then negative 1's not going to work, so we're going to use 0. So therefore, our domain starts at 0. So this is going to be the leftmost value on the graph, right? Okay, so now you want to think to yourself, is there a function value that exists at 0? Was there an output for our given input? And the output we got was 0, right? So because that this value exists, right, the y value exists there, then we would say that there is a closed circle on the graph at 0, 0, and therefore we're going to use a less than or equal to sign in our inequality notation. Okay, so you have two choices when you're writing the domain and range. When you're using inequality notation, you're either going to use a less than sign or a less than or equal to sign. So when you're going to use a less than sign, you would see an open circle on the graph, all right? Or you're going to see one of the infinities, right? If you use a less than or equal to sign, you're going to have a closed circle on the graph, right? That means that the function value exists there. For the given input, there exists an output, right? So it all depends on the graph, all right? So now you can use this down here as like a little key, right, which will come and help when we also do the range, all right? So now we want to look at the rightmost value. So the leftmost value on the graph is 0, right? You want to draw like a little line here to show that it won't cross it, right? That's the leftmost value on the graph. You don't have to do that. That's not. Now you're going to look to the right. So what you kind of want to do is I'll highlight. As you go to the right, where does your function go, right? The arrow should show you that it keeps going to the right forever. And when this happens, we say the function is going to positive infinity. So if you kept going to the right, you're like never going to stop, right? Because it's continuous to the right. It'll just keep on going. So we say that the domain technically ends at infinity, even though it's not a number. So I'm going to write that in. So positive infinity is where the domain goes. It's going to keep going to positive infinity. Now we need our inequality notation. So look down at your key. If there's an open circle or infinity, you're going to use a less than sign, right? Because you can't include infinity. It's not a number. So therefore, it wouldn't make any sense to use the less than or equal to sign, right? Because you can't equal infinity. All right, so this is, I'll write down right here. So you're going left to right, and then you're going to choose which inequality sign to choose, less than or less than or equal to. So here we have it. This would be our domain. Okay, now let's talk about the range. So I'm going to erase this. Okay, so if you look back at the equation, f of x equals the square root of x. Now we're thinking about range. We're thinking about the output. Right? Domain was input. All right, so looking at the function, let's first look at the equation. All right, you want to think, what is the smallest, or in other words, most negative y value you would ever get? What's the most negative output you would ever get from the square root of x? And what's the most positive or the largest y value you would ever get? So obviously from the graph, it could be a little easier here, but look at it algebraically, right? What is the smallest number you could receive as an output here, right? Are you ever going to get a negative number as an output? Well, no, right? We figured out that that didn't work out, right? We got an imaginary number. So what's the smallest y value you would ever get? Well, wouldn't it be 0, right? Because when you substitute in 0 for x, you get back out 0. So the smallest output you could ever get is 0. Now look at the graph, right? You're going to look bottom to top now. What is the lowest, most bottom y value on the graph? All right, so you're going to look up and down. What's the lowest y value? Well, it looks like, right, it doesn't go below the x-axis, so where y is 0. So right here is the lowest point on the graph, right, 0, 0. So for the range, it's going to start at 0. And I'll do this in pink to show y values, okay? So because the lowest most, the bottom most y value on the graph is 0, that's where our range is going to start. So if you want to think of this as the bottom, we're going to go bottom to top now when we're looking at range. All right. All right. Now, hopefully you guessed it, we're going to figure out which inequality sign to use. Well, look at 0, right? Is it a closed circle? Does the function value exist there? Well, yeah. So we're going to use, again, a less than or equal to sign. It was the same coordinate as the one in the domain, right? So it's going to have the same inequality sign. Okay, so now we're going to look at the topmost point or the highest point on the graph, right? Is it a number or is it going to be an infinity? That's our two choices there. So looking back at the equation, what's the largest number you could get from the square root of x? Is there an x value, an input, where it would eventually stop giving you an output? Or can you take the square root of anything that's positive forever and ever? Well, think about it. Square root of 100, 10, right? You just keep going up and you're still going to be able to get outputs for any input, right? As y increases over time. So look at the graph now. I'm going to highlight like I did last time. As we go up, where do the y values go? Does it stop at a certain value or does it keep going up to positive infinity? Well, because of the arrow, we can say that this guy's going to go up to positive infinity, right? It's going to keep on going up forever. So if I go back to our range at the bottom here, our notation, this guy is going to go up to positive infinity. Now we have to figure out what inequality sign to use. We learned that infinity, you're going to use a less than sign because you can't include infinity. It's not a number. All right, so there you have it. You have your domain and your range. All right, the key is domain is left to right, range is bottom to top. So if I read this out loud for the domain, this is saying that x is always greater than or equal to 0 and always less than infinity. For the range, we're saying that y is always greater than or equal to 0 and always less than infinity. So as you see, the domain and range look the same, except for, of course, the x and y.